I started recording that, but it's too late. So quickly, I recap this. We're doing a counter that will count by 3, adding 3 each time. Starts from 0, and the highest 15. So once it hits 15, it goes back to 2, then 5, 8, and so forth. There are 16 states. We started this, so now we're going to get back to it. And so we decided we need 4 flip-flops, because 2 to the power of the flip-flop should be greater than or equal to the number of states. Since I have 16 states, I will need 4 flip-flops. And we give them actually the binary value for 0, 0, 0, 0, for 3, 0, 0, 1, so we know where we are. I wasn't planning on recording this, but since a few requests for it, so I'm jumping back in. If you're just watching the video, that's why. Now I need to go from state diagram to the table, state table. So I have there is no outside input, just the clock comes in, you jump from here to there, next clock you go to this, next clock to this. So the only input you have is really the clock and whatever the current state, the flip-flop. So I have 4 flip-flops. I'm going to use the most significant as 3, Q3, Q2, Q1, and Q0. And the next state again, 3, 2, 1, 0. These are the next state. We'll put asterisks on them. So if you are state 0, 0, 0, and the clock comes in, what happens? Where do you go?
0, 0, 1, 1.
To 3, 0, 0, 1, 1. If you are state, we'll put them in order here. If you are state 1, 0, 0, 0, 1, the clock comes in, where do you go? 4. If you are state 2, just add 3 to it. What's 2 plus 3? 5. So where are you going to go? 0, 1, 0, 1. Notice if you are state 2, where am I 2? The clock comes in, you go to 5. If you are 3, the clock comes in, add 3 to it, that's 6. And we'll keep going with that. If you are state 4, oh, I need to put a 1 here, not a 0. That's state 4. The clock comes in, what's 4 plus 3? 7. If you are state 5, 5 and 3, 8. If you are state 6, 6 and 3, 9. If you are 7, that's 10. State 8, 1, 0, 0, 0. The next one should be what? 8 and 3, 11. 11 is 8, 2 and 1. If you are state 9, the next one should be 1, 1, 0, 0, 12. If you are state 10, 10 will be 1, 1, 0, 1. If you are state 11, this will be 1, 1, 1, 0. 12. 12 and 3 is what, 15? 1, 1, 1, 1. 13. The next one's 3 more. Think about 13. 14, 15, it goes to 0. 14, it goes to 1. And 15, it goes to 2. So hopefully we got them all. Now we got to decide what kind of flip-flops we're going to be using. Do we know what kind of flip-flop you want to use?
JK.
JK, okay. Let's pull that JK flip-flop. I don't have one with me, but if you remember, there's the JK flip-flop. I'll just write it on this pink piece of paper. Then maybe we'll take it, put it on the top. This is J, K, and Q next. If it's 0, 0, it's going to stay the same. Q previous, right? 0 to 1 is going to be what? 0. 1 to 0 is going to be 1. And 1 to 1 is going to be the previous one complement. That's the JK flip-flop. So let's look at the excitation table. From the current state to the next state, what is J and K should be? From 0 to 0. 0 to 1, 1 to 0, and 1 to 1. Zero to 0, I could get to it by making J0 and K0, or if I put 0, 1, that will guarantee I have a 0. So as long as J is 0, don't care about K. Zero to 1, I can get to it through 1, 0, will make it a 1, or 1, 1 will complement. J is 1, don't care for K. 1 to 0, I can get to it right here. If you put 0, 1, it's going to force it to be 0. Or also the complement.
Don't care 0.
Don't care 1. And 1 to 1, I can get to it either right here, keep it the same, or right here. And that's what? Don't care 0. So that's the table I'm going to be using. So if I cut that and stick it to my paper so I don't have to use multiple sheets, and with the pretty color like this will stand out. There we go. I can stick it to this page down here, somewhere there. Where's my tape here? Oh, down there. I'm going to need highlighters. I get 3 of them. I'm going to need 4, so one of them will have no highlight on it. There we go. Come on, come on. I'll move it down this way. So this way when we scan the notes, it doesn't get caught somewhere there. Get stuck on it. So let's look at this. So I got to do J1, K1, J2, K2, J3, K3. So here is the third one. I'll do in the same order. So J3, K3 here, J2, K2, J1, K1, J0, K0. And Jay-Z and Beyonce. There we go. So let's look at the first one, the 3. We'll use the yellow color for it. So I'm going to be looking at this column, this one. I'm going to be putting the result right here and right here. Again, keep your eyes open. It's really, really easy to make a mistake. God knows I make them all the time. I see the first 1, 2, 3, 4, 5, 0 to 0. That's 0 and don't care. Then I see 1, 2, 3, 0 to 1. 1 and don't care. Then I see, how many? 5 of them? 1, 2, 3, 4, 5. 5, 1 to 1. Don't care and 0. Then the last 3, 1 to 0. Don't care and 1. Somehow I'm off track here in terms of.
You skipped a line down there.
Yeah, I think. But the numbers are there 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. They're there, they're just not perfect. You know? So somehow I've got to readjust them. I think I have one of these high a little bit there, so I'll just get rid of it.
No, it was the 4th one down. You skipped a line.
4? Oh, I see here. Well, I tried to line them up with this. That's what I tried to do. I think these, I was tight on them up there, but I wasn't here. They match, actually, but they're not the same line. A little bit off there with the line. But all I care about is really this table and this. It looks like I missed, but I didn't miss anything. But right this, I tried to write them in each box, where these, I wasn't in one box. So that's the second one. Okay, 0 to 0. 0 and don't care. I got 1, 2, 3, 4. 4 of them 0 to, no. 3 of them 0 to 1. 1 and don't care. 3 of them. Then 1 to 1. There's only 1 of them. Don't care and 0. Then 1 to 0. 1, 2, 3, 4, I think. 1, 2, 3 of them, 1 to 0. 3, 1 to 0, don't care and 1. Then 0 to 0, 1 of them, 0 and don't care. 0 to 1, 3 of them, 1 and don't care. 1 to 1, don't care and 0. And 1 to 0, 3 of them, don't care and 1. I made them a little bit bigger so it looks like I didn't miss anything. Now we got the next one, Q1. And that will be this column and this column. 0 to 1, 1 and don't care. 0 to 0, 0 and don't care. 1 to 0, don't care and 1. 1 to 1, don't care and 0. I don't like this one. Changes a lot. 0 to 1, 1 and don't care. 0 to 0, 0 and don't care.
Or does it just repeat?
I don't know.
It does.
It does?
Yeah, all the way down.
All the way down? So repeat what, the first 5?
4. It goes.
Don't care, 1, 0. Don't care, 1, 0. Okay. Oh, that's a 1, 0. Don't care, 1, 0. They might not line up. Don't care, 1, 0. 1, 0, don't care, 1, 0, don't care, 1, 0, don't care, 1, 0, don't care.
The last one is just 1 don't care, then don't care 1 all the way down.
Which one?
The JK or J.
1?
It's gonna be Q0. It's gonna be 1.
Oh, the last one?
All the way.
It's going to be what? 0, 1, 1, 0, 0, 1. Oh, yeah, alternate. 0 to 1, 1, 0. 0 to 1 is 1 and don't care. And the next one is 1 to 0.
Yeah.
1 to 0, don't care, and 1. So alternate these. Don't care, 1. Oh, this is perfect, because you group them. What do you have? VCC, right? You make them all 1s. 1 don't care, 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 1 don't care. I hope I don't have more than what I need. But that's how it looks like.
Yeah, you have the right amount. The
Yep.
K0 is just stretching down more.
Yep. So now I'm going to make, I can either use, like we did last time, the last video we used what? Flip-flops, decoders, encoders, everything. PLA, PAL, we did everything.
Are you gonna tell us what to use on a test?
Yep, I will. No, I will. I'm just looking for the one that doesn't have that many 1s in it. So maybe for this flip-flop, the third one, because it has only a few 1s in it. So maybe what I'll use for that decoder, a 4x16 decoder, one of them, and some OR gates. This one, maybe I will use muxes, multiplexers. That's 8x1. I will need 2 of them. Maybe these, I'll just go back and use K-map. And the same thing here. I'm going to mix and match what to use for each one to drive each flip-flop. If you notice actually this here, if you do a K-map for this, you're going to have 1s and 0s in it. Right? So let's do a K-map. Oh, I might have some here. Come on, I'm sure. Oh, there's some K-map. So this is for J0 and this is for K0. We'll go through them. And this is for J1 and K1.
Isn't it just always on?
Yep. Well, let's see. Q3, Q2, Q1, Q0. Notice for J, 1, don't care, 1, don't care. And it repeats, 1, don't care, 1, don't care. You can group the bottom and the top. Or you can take all 8 of them. So if you take all 8 of them, go, well, all these disappear, what do you put? Because you want them to be 1. It better be VCC. You make them all 1s. And the same thing for the next one. Except for K, this is going to be what? Don't care 1, don't care 1. And it repeats. So what's this one? That's also VCC because you've taken all of them. Now let's look at J1. One, 0, don't care, don't care. 1, 0, don't care, don't care. And it looks like it repeats its pattern, right?
Yeah, it should
What?
stay
Yep.
with that pattern.
So for this one, obviously, I'll take these 4 with these 4. Q1. I mean Q0 not, yep. And for K1, and it repeats.
It's the exact same thing, Q0 not.
So you get to think, like, maybe I planned it that way. So this one is going to be what? Q0 not. Same thing. So we did J0, K0, J1, K1. Simplified that. Done with it. Now let's look at J2 and K2. I'm going to use 8 by 1 muxes for them. 8 by 1 mux. Okay, let's look at 8 by 1 mux. So this is J2 and K2. So this is what's going to J2. And this is K2. Since it's 8 by 1, how many control signals, select signals you should have?
3.
3. And if you use the most significant ones, it makes it a little bit easier on you. So I'm going to use, for select signals, I'm going to use the most significant, Q3, Q2, Q1. Q3, Q2, Q1. I have 8 inputs, 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. Let's put the ruler on it. When there's 0, Q1, Q3, Q2, Q0, zeros. This is J3. We're doing J2. This is J2 and K2. Look at K2. It says what? We don't care. So I'll wait on that. That's don't care. But what about J2?
Whatever Q naught or Q.
Q0. Yep, whatever Q0 is. 0, 1, 0, 1. The next group, the next two. That looks like another don't care, but this has to be what? VCC. The next group, 0, 1. That's 0, 1, which is what? This is Q0 for the K. And this will be what? Don't care. What's up to you, don't care? Since you got the VCC here, might as well attach the VCC here. Since we don't care about this one, could I attach Q0 to it? These two? It's right there. You got a wire right here. Why bring a wire from here, from this end of the table, VCC to there, or ground? You got Q0 attached right here. So maybe what I'll do, I'll move these down, and I'll make them all touch it. Because you don't care what that value is. Doesn't make a difference what you attach to it. And since I got a Q0 there, I go, you know what, I'll tap to it. Now, 0, 1, 1. VCC and don't care. Don't care. So since you don't care, you get VCC here attached to it. 1, 0, 0. Don't care, and what do we have here? Q0. And don't care here, maybe I'll go to VCC. I already have the wire. One, 0, 1. Don't care in VCC. Don't care. And VCC. One, 1, 0. Don't care here, so go VCC.
You can't see.
And the other one, 0, 1, which means the same as Q0. 1, 1, 1, can you see? Uh-oh. I'm in trouble. Oh, God. They weren't lining up. Oh, no. I might be okay. Where am I? 7, 1, 1? Good. Yep. Don't care and VCC. Since you don't care, attach the VCC then. And for J3 and K3, 4x16 decoder. So it has 4 inputs, 16 outputs. Only one of them will be on at any given time. Only one. So it can't be an AND gate to it because an AND gate will kill it. It has 4 select signal control signals, Q3, Q2, Q1, Q0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. I'm going to have 2 OR gates. One for what? J3 and one for K3. You want J3 to be 1 where? At 0, 1, 0, 1. Oh, can you see it? Here we go. 0, 1, 0, 1. 5, 6, and 7. I'm not going to run the wires. I just write the address. Take it from 5, 6, and 7. Go right there. And you want K3 to be 1 where? The last 3. Can you see K3 here? The last 3. 13, 14, 15. Now we've got all these pieces ready. I just got to take them, feed them to my flip-flop.
How did you know what you wanted wanted those to be on for that vehicle?
That's where the ones are.
Okay, you don't do anything with the...
Don't care? Since you don't care, why make it complicated for you? Right? Why should you connect these wires? Just you gotta buy the wires, even just the wires themselves. You gotta stretch the wires, connect them, something's gonna get through. I'm only gonna attach what I need to be one. The rest, I don't care, I'll make them zeros. So now it's gonna build a circuit. I got 4 flip-flops. Here's the first flip-flop. So that's the first flip-flop. So that's number 3. On the left, number 1 on the right. J0, K0, Q0, Q0 not, Q1, Q1 not, J1, K1, Q2, Q2 not, J2, K2, and what? Q3, Q3 not, J3, K3. The K-map. What was attached to J0 and K0? VCC. So you take a wire here, you go, okay, I'm going to attach these guys to VCC. Both of them. J1, K1, what's attached to it? Q0 not, right? So right here, these guys here, together, what's attached to them is this one. Now J2 and K2, I gotta draw my muxes there. And I don't really have enough space there, so I'll put the first mux on the top. Second one on the bottom. So this is what's going to J2, and this is what's going to K2, and I'm just copying these two, Q3, Q2, Q1. And I'm not gonna, I just go Q0 here, VXX on the first 3. or VCC, I mean. Then on the pin 4, Q0, 5, 6, and 7 VCC. This one, Q0 to 0, 1, and 2. Q0. VCC 3, 4, and 5. Then Q0, then VCC. Again, when I say Q3, Q2, Q1, you're going to attach this one, that one here, and Q0 is this one. And if there's Q0 not, we attach that one to it. I'm not running the wires to it. And this one here, I'm going to lay my decoder upside down like this. Because I don't have any space there. 4 by 16 decoder. Q3, 2, 1, 0. I got 16 outputs. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What are you going to attach to K3? It's an OR gate. And which one of these is going to be attached to it, to K3? Where's my K3? K3, 13, 14, 15. And for J3, 5, 6, and 7. So you take the wires from here and attach them right there, and that's my circuit. And there's only one thing we left out, and that's what? The clock. So we just got to attach clock there. So as the clock comes in, they all click at the same time. So this could be my clock. CK is the clock. It's going to all of them. So the clock comes in, trips them all. So okay, start with 0. And as you click on them, as the clock comes in, that's your switch. It goes to 3, 6, 9, and it keeps going. And that should be the design of that circuit. 4 JK flip-flop, 2 multiplexers, 1 decoder, 2 OR gates. Did I have to use the multiplexers and OR gates and decoders? Absolutely not. I could have did a K-map for them. Simplified each one. And just use gates. I'm just trying to mix and match the stuff we learned, kind of review for the final exam.